you see, y be the function of x is the independent variable, but y is dependent variable. So here y is a function of only one independent variable. So we differentiate this dependent variable with respect to the independent variable. With respect to x one time 2x, with respect to x second time we get 2, the third time is 0. Right? See the example. What is the displacement function s? S be the function of time. Remember? Isn't it? Displacement is a function of the time factor. So what is the rate of change of the displacement s with respect to time t? It is called the velocity. Sorry, this is the first order derivative. What is the rate of change of velocity with respect to time t? It is called the acceleration. Otherwise, what is the rate of change of displacement with respect to time t? So this is d by dt of v. What's a v? V is ds by dt is equal to d squared s by dt square. So this is the second order derivative. Right? Now see, the ordinary differentiation, when it happens only when the dependent variable is a function of only one independent variable. See that is x here it is a displacement is a function of time t. So only those cases it occurs the ordinary differentiation. Now can you guess what is the order? The order is, when we differentiate only one time, it's the first order. When we differentiate second time, it's called second order. The third time, third order. So continue like that. So what is the order for the acceleration? It is the second order, because we can differentiate the displacement with respect to time t 2 times. What is the order for the velocity? The velocity is only one time, so that is the velocity is nothing but the first order derivatives. What is meant by partial differentiation? Let us see the example. See. If I consider z is equal to x cube y square. See that? Z is equal to x cube y square. How many variables are there? Namely 3. What are they? X, y and z. Right? Let us see. If I substitute x, y values, what's the corresponding z value? If I assume that x is equal to 0, y is equal to 0, z is also 0. Right? Suppose x is equal to 1, y equal to 0, once again it is 0. Suppose x is equal to 0, y is equal to 1, once again it is 0. Suppose x is equal to 2, y is equal to 1, that is 2 cubed is 8. Suppose x is 1, y is 2, then 2 squared is 4. So, when we assign just like that the values for the variables x and y, can you guess what is the name for these two variables? Nothing but, yeah, you are correct. What is it? It's an independent variable. Am I right? Isn't it? Because these two variables are freely assigned the values just like that. But this is completely depends upon the both x and y. Both x and y. Right? So it is very clear that z is a function of more than one independent variable x and y. So here z be the function of more than one independent variable. I think so we have already discussed in detail about this types of functions in the very first semester, functions of several variables. Am I right? Functions of several, more than one independent variable. So here z be the function of more than one independent variable x and y. Now you see, at a time we are going to differentiate any one of the independent variable, not all. It's not possible. So when I differentiate z with respect to x, what about z? Z be the function of x and y. So when we differentiate z with respect to x, what we assume that? We assume that the other variables are constant. We assume that the others are constant. So we can do the partiality among the variables. So that's why this is known as partial differentiation. So I use a notation for partial is dou. Ordinary means I use d. partial means a slight bending, so it's called a dou. Okay, dou. Dou z by dou x. So when we differentiate z with respect to x, we assume that y is a constant. At the same time, when we differentiate z with respect to y, we assume that x is the constant. But because z is a function of both x and y, so both are variables only. Both are variables. It is a function. It will affect the z value. At a time we do any one variable as differentiation, so the other is treated as a constant. So we can do the partiality. That's why this is called the partial differentiation. Got it? Clear? Now see, in this example, can you guess what is dou z by dou x? So this x cube y squared. So what is y squared? Y squared is constant, right? What about x cube differentiation with respect to x? It is 3x squared. So the answer is 3x squared y squared. Is that right? So right, once I repeat this, z with respect to x only, here it is x cube. What about y squared? Y squared is constant. So we keep as it is the y squared there. And x cube differentiating with respect to x, we get it is 3x squared. The same way, when we differentiate z with respect to y, we assume that x cube is a constant, isn't it? So what about y square differentiation? This is 2y. So this is the dou z by dou y, 2x cube y. So this is only one time. This is called first order partial derivatives. Clear? Understand? And once again, can we go for the second order for the same example? What is second order? If I differentiate z with respect to x second time. Already we did the first time. Now I go for second time. What is second time? Let's see that dou by dou x of dou z by dou x. So what is dou z by dou x is already there. 3x squared y squared. Is right? Once again differentiate this 3x squared y squared with respect to x. So 3 is a constant. X squared becomes 2x because with respect to x, and y squared is retained the same. So the answer is 3 2s are 6, 6x y squared. Right, sir? It's clear with respect to x twice. In the left hand side, this is dou into dou squared, dou x into dou x squared. So this is called dou squared z by dou x squared. Once again, I can do this x second time. Can I try the y the second time? Let us see. Dou by dou y of dou z by dou y. Dou by dou y of dou z by. What's the meaning of this one? Second, sir, I can use this from right to left idea. Right to left. See that? So it's equal to dou by dou y of. What is dou z by dou y? Already we have. It is 2x cube y. Is right? So already first time is we did with respect to y. So take that resultant value, take that output. Again we differentiate that once again with respect to y. So once again with respect to y means what about 2x cube is a constant. So it is 2x cube. What about the y? Y is with respect to y it is 1. Y with respect to y is 1. That's right. So this is the second order partial derivatives with respect to x is with respect to y. And one more final technique was there. The technique is called mixed partial differentiation. Mixed means x and y. Okay, let us see that. I can take this dou z by dou x value. This is did first time with respect to x. I want to take the same, but this time I would like to differentiate this with respect to y. So what's the meaning of that? Dou by dou y of dou z by dou x. What is dou by dou y of dou z by dou x? So what's the meaning there? From right to left concept, dou by dou y of what is dou z by dou x? 3x squared y squared. Sir, already we did the z with respect to x, that is 3x squared y squared. But this time I go for with respect to y. With respect to x already there, here. X second time. But this time we go for the another variable y. So this is equal to 3x squared is constant. Y squared with respect to y it is 2y. So the answer is 6x squared y. Clear? There's one more technique is there. If I use dou z by dou y value, what is dou z by dou y? Z with respect to y. I can pick this output and do with respect to x second time, because already y is one time over. So this is the second one, dou by dou x of dou z by dou y. Okay, is equal to dou by dou x of, what is dou z by dou y? 2x cube y. This is 2x cube y, already we have z with respect to y. That is dou z by dou y. So I can pick that one, do once again with respect to x. So this is equal to, what is the x cube differentiation? 3x squared. So 2 into 3x squared is 6x squared y. So I think so it's the same. So this is called the mixed partial derivatives. When we go from first x then y, or first y then x, both are same. This is called mixed partial derivatives. This is same for any functions. So these are the second order partial derivatives. Z with respect to x twice, Z with respect to y twice, Z with respect to x one time, y one time. You can change the order, it's called mixed. First y then x, or first x then y, whatever the output, the result value is same. Okay, so the first order partial derivatives are called, are denoted some standard notations throughout this unit. Number 1, what is z? Z be the function of x and y. It's clear? So when we differentiate z with respect to x, z with respect to y, we get the first order partial derivatives. When we differentiate z with respect to x twice, so dou square z by dou x square, dou square z by dou x dou y. I use the mixed partial derivative. Dou square z by dou y dou x. I think this is the same. Okay. What is dou square? Dou into dou square. Dou y into dou x. So dou y into dou x. Okay. Dou into dou square. Dou x into dou y. So dou x dou y. And finally, dou square z by dou y square. These are called the first order partial derivatives because we do only one time. These three are called the second order partial derivatives. So throughout this unit number 1, I use the notations for dou z by dou x is p, dou z by dou q is dou y is q, and r s t. So you know the English alphabets, p q r s t. Very simple. P and q stands for the first order partial derivatives. If z be the function of x and y, p is dou z by dou x. This can be also written like this, z suffix x, z suffix y. Yeah, suffix represents the variable with respect to x or y. Okay, got it? So this is the little bit introduction about the ordinary and the partial differentiation ideas. Thank you.